So our image looked kind of like this, where we had height and time. It was projected upwards, came back down, and over time, as time passed, after 9.04 minutes, or seconds, excuse me, the missile is projected to land on the ground. Okay, so it hits there, but this is a mathematical function. So the mathematical function doesn't just begin here and then go from there. If you started to work your way backwards in this thought process, if the slope is flattening out as you go forward only to get more and more steep, well, then you can also say the same thing for going backwards. Well, 1 unit ago the slope was steeper. 1 unit ago the slope was steeper. And so you kind of get the shape going in both directions, even though we typically start at the initial value. So somewhere over here at this point, negative 1.04, we also encounter an output of 0. At 9.04, we encounter an output of 0. So we actually have two places where, you know, the output is 0. However, this one doesn't really make sense because the missile was projected from here, but the function mathematically goes on in both directions. So that's why we get two values, two places where that occurs. Okay, well, next we want to know, going back to our question, if the missile is fired at a helicopter 50 feet off the ground, how long will it take for the missile to land? Okay, so we have a, if we think about this, we basically want to know, once it's fired from 150 feet, when will the object, the missile, be at a height of 50 feet? So on its way down, it'll eventually hit a height of 50 feet. So we want to know, when is the height 50? And we're going to use our vertex form in the exact same way as we did earlier. So the beauty of this process is that we do the same thing every time. There's really nothing new here. Subtract 406. Now in this case, we have negative 356 equals negative 16t minus 4 squared. Divide by negative 16. And we get 22.25 equals t minus 4 squared. Okay, well now I take the square root to cancel out the square. Take the square root, but realizing that I could have the positive or the negative. That gives me square root of 22.25 will give me about 4.72, that's plus or minus, equals t minus 4. And in the same way, I'm going to add 4 to both sides. And I get 4 plus or minus 4.72 equals t. And so I have two possibilities. I can do 4 plus 4.72 or 4 minus 4.72. And if I do 4 plus 4.72, I get 8.72. And if I do 4 minus 4.72, I get t equals negative 0.72. So again, this doesn't really make, one of these answers doesn't make sense if you continue going back this way. Well, yes, mathematically there'll be another point where you have a height of 50, but we're only interested in this one here, which we just found was 8.72 seconds. So after 8.72 seconds, we would expect a height of 50 feet. So it would take about nearly 9 seconds for this missile to land. But if we wanted to be precise, 8.72 makes a difference because if this helicopter begins to move, then we may just miss it or we may overshoot it. That basically brings up our solutions. But suppose we wanted to ask the question, when is the height of the missile 500 feet? So now in this question, we want to know, let's just say there's an object that needs to be fired at 500 feet from the ground, and these same parameters take place. Well, if we go through the same process, first of all, we know that the maximum height is 406. So we can right now say that this is impossible. But if I run through the steps, I get 94 equals negative 16 t minus 4 squared. So I want to just show that the math is going to work out funny. So what number times itself is going to give me negative 62.125? Well, unfortunately, there's none. A positive times a positive is a positive. A negative times a negative is a negative. Our calculator is going to give us an error. That means we can't do it.